Hello everyone, welcome back to my YouTube channel LinuxGKTech. My name is Gautam Kumar and I am a certified Kubernetes administrator. In this session, we will discuss about how to set up a Kubernetes cluster using kubeadm on Ubuntu 24.04 LTS. So before starting installation, we will discuss about Kubernetes cluster architecture, simple architecture, and what is kubeadm, and what are the prerequisites to set up Kubernetes cluster using kubeadm. So, friends, you can see here this is a simple architecture of Kubernetes cluster, and in which these area are belongs to control plane node on the APIs, scheduler, etc. All these components are running, and these area are under worker node. We have a two node, node 1 and node 2, and in node worker node, two services are running, kubelet and kubeproxy. So now we will discuss about what is kubeadm. Kubeadm is a tools to set up a Kubernetes cluster without much complex configuration. Kubeadm makes the whole process easy by running a series of pre-checks to ensure that server has all essential components and config to run Kubernetes. It is developed and maintained by official Kubernetes communication. Now we will discuss about prerequisites. So prerequisites, these are the prerequisites. The first one is you should have Linux-based distribution on Debian and Red Hat, and you should have 2 GB RAM and 2 CPU for control plane node. And for worker node, you should have at least 1 GB RAM and 1 CPU. Apart from this, full network connectivity between all machines in cluster should be available. And unique host name, MAC address, product UID for every node should be there. And certain ports should be open on your machine. So please refer this architecture to open the port on all control plane node and worker nodes. Now we will discuss about the steps in short that we will perform in Kubernetes cluster setup. So the first step is to install container runtime on all nodes, and we will use container D. And the second steps will be to install the kubeadm, kubelet, and kubectl on all nodes. And the third step will be to initialize control plane configuration on control plane node. And then we need to save the node join command with token. Then we need to install RevNet plugin for pod network. And the sixth step will be to join the worker node to the control plane node using join command. And then we need to validate the cluster components, and we can run here kubectl get pods and kubectl get nodes command to verify. And in last, we will deploy a simple app in Kubernetes cluster with deployment and service. So now we will discuss the installation part in a step by step. The first step is to enable the IP tables bridged traffic on all nodes. So for this, we need to run these commands one by one on all nodes, or we can simply copy these commands and we can run on all nodes. So let me show you the nodes. Yeah, I have three nodes. One is for control plane and two is for worker node. I have created VMs using Vagrant on my machine. You can see three nodes are running: control plane, node 1 and node 2. And if you want to know the script for this Vagrant file that I have created to create these VMs, then you can visit my GitHub repository. I will share the link in video and you can read the script. I will show you here in short. Okay. Yeah. So this is a script in which I have written the simple code to create control plan node and two worker nodes. Okay. So now I will connect this machine and will run the commands. Okay. I will run all commands on all nodes. Okay. Okay. So now I will move further to step two, where we need to disable the swap off. You can disable the swap off temporarily using swap off space hyphen a command. And if you want to disable the swap permanently, you need to disable an etcfs tab file. And if you want, you can do that. Okay. Okay. I have done. Now, if I check the swap, you can see 0, 0. Okay. Now, in a step three, we will install the container D runtime on all nodes. And the basic requirement for a Kubernetes cluster is a container runtime. You need to install a container runtime into each node in cluster so the pod can run. And you can install any one of the following: CRI Hafnano, Container D, and Docker Engine. There we will use container D, container runtime. So to install the container D, we need to run this command on all nodes. Okay. If you want to read, you can read. But if I will explain each command, it will repeating will be too much long. Okay. Yes. 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 Okay. It will take some time. Yes. So in a step four, we will configure CRI-CTL tools, and we use CRI-CTL tools to manage the container D and to troubleshoot the container D. And if you are preparing for CK exam, you should must have hands-on on CRI-CTL tools because you need to troubleshoot the pods and container status containers in exam. So for this, first of all, we will set two variables. First variable is for version and second variable is for architecture, because my VMs are under ARM architectures. So we need to set this variable and we need to run these three commands to install CRI/CTL. If your VMs are under AMD architecture, then you need to run these three commands. And in last, this command you need to run either you are on AMD or ARM architectures. Okay. So let me check my terminal. Okay, done. So let me check the variables first. Okay, okay, I have done. Now, okay, I will run this command to install share cdf packages. Okay, I will run this command on all nodes. Okay, okay, completed. Fine. I will run this command to extract the tar file. Okay, fine. So the third step is to remove the tar file because we have moved the CRI/CTL packages under user local bin. Now we do not require the tar file. So we will remove from all nodes. Okay. Okay. Done. So now we will run this command to configure CRI/CTL to use container D socket. Okay. Okay. Done on one node. Okay, fine. Now we need to restart container D on all nodes. So we have done CRI/CTL installation. We can check the version using this command. Okay, this there is a typo. Yeah, you can see. You can run another command. CRI/CTL PS. You can see. At this moment, there is no process. There is no containers are running at this moment. So in Docker, you use Docker PS. In container D, you can use CRI/CTL PS. Okay, fine. Now we will move further to step 5 where we will configure system D C group. So I have written in details what is C group, what are the types of C group, what C group done, why we use C group. So if you want, you can read this article. Now here I will simply enable the system D C group on all nodes because if I will explain, then video will be very long. Okay, I have done. Now we need to restart container D on all nodes. Okay, fine. I have completed step 5 and step 6. We will install kubeadm, kubelet and kubectl on all nodes. So first of all, we will run these two commands on all nodes to update apt repo and download all necessary packages. Okay, then we will run this command. We will set variables and we will download GPG key for Kubernetes apt repository on all nodes. Okay, you can run all commands one by one. I have copied. Okay, I have done. Okay, fine. Now I will move further. Okay, so we need to update apt repo once again on all nodes. Okay, so okay, you can see the Kubernetes repository has been added here. Okay, the last step. Okay, before that, we can run this command to find the latest version. Okay, so you can see the latest version of kubeadm is this. We will use this version. Okay, so for this, first of all, I will set the variables and then we'll install. Okay, 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 fine. So, or you can directly run this command. This command will install the latest version of kubelet, kubeadm, and kubectl. And in last, you need to add this, run this command to hold all the packages to prevent the upgrades. Okay, so let me check. Okay, completed. Okay, fine. So now we will move further to step 7, where we will initialize kubeadm on control plane nodes. So these are the critical part that I will explain the component like control plane endpoint and what is kubeadm, what kubeadm init into, and what is pod CI. So you can read these part, and if you If you have any doubt, you can ask in comment section. Okay. So now I will run this command directly on control plane. So okay. So let me modify update API advertise address, and that will be control plane node IP and port network CIDR. This is a default one if you use webnet network plugin. So, or if you want to different range, you need to modify the webnet YML file before installing the webnet. But I will keep by default. Okay. So now I will run this command simply. Okay. So it will take some time, 2 to 3 minutes to complete the kubeadm initialization. So friends, finally Kubernetes control plan has been initialized successfully. Now we need to run this command if we want to control using non-root user. So simply I will copy these three commands and will run on control plane nodes. Okay, I have done. Now we need to set up webnet network plugin. You can use any another network plugin as per your preference, but I will use webnet here. So for that, I have written the command on my website. I will move further and will install webnet network plugin for pod networking. So simply you need to copy this command and you can run on control plan node. Okay. Okay, so you can see all the objects have been created on control plane node like service account, cluster role bindings, role bindings, demonstrate. So friends, one thing I want to share here, if you are creating the Kubernetes cluster, you should have basic understanding. You should must have basic understanding of what is the pod, what is the deployment, what is the service, what is the cluster role. Then only you can understand how to create a Kubernetes cluster. So if you don't know, I will suggest to read about this. First of all, you understand the basic architecture of the Kubernetes cluster and the components of the Kubernetes architecture. Okay, so now I will move further and I will join the worker node to this cluster. For that, we have already command this. We need to run this command on all worker nodes. So simply I will copy this command and I will run on worker node as a root user. Okay. Okay, done. And I have two worker nodes, so I have executed on both. So now, if you will run the command kubectl get nodes, you can see the two worker node 1 and node 2, not in ready state. It will take 1 or 2 minutes. Okay, so you need to wait 1 or 2 minutes. Another thing I can show you kubectl get ports command. Okay, there's no port. But if you will hyphen A, you can see uh, all okay webnets, all ports are running. Okay, fine. Retail get nodes. Okay, in ready state. So friends, here we have completed the setup of the Kubernetes cluster. Now we will deploy a simple Nginx application on this cluster to test. So you can copy this deployment and you can run on control plane. So for this, I will create variable file. So here you can see the kind of deployment and Then I have defined the name of this deployment, and this is a label Nginx app, and the image is Nginx by default, and the container port is 80. So now I will simply save this file and will create a deployment using kubectl create fly hyphen f. Okay, deployment created. You can see kubectl get ports. Ports are creating. So friends, you can see the ports are running and service also created. We can check the service detail using this command. So we can access our application using node port with control plane node IP. So let me show you how we can access. The node port is 32000. So yeah, so finally you can see we can access our application from outside using node port. And I have copied these codes to create service. So friends, here I have completed this video. So if you like this video, please subscribe my YouTube channel, and you can also share this video with your friends and colleagues. Thanks again for watching this video.